Officially named Republic of Colombia, Colombia is named after Christopher Columbus, despite the Genoese navigator never having reached it. The locals have fun anagramming its name in Locombia from the term loco, which means crazy. More than a crazy country, Colombia is certainly one of the most diverse countries in South America for its flora, its fauna, and the variety of ethnic types that make up its people. But Colombia is mainly a country rich in water resources. It is crossed by the Andes mountain range, which generates numerous rivers and has a huge potential for hydroelectric power exploitation, navigability, agriculture, fisheries, and tourism development. The most important river, with a distance of about 1,550 kilometers, is the Rio Magdalena. This river is the axis of the hydrographic system of Colombia and was formerly known as El Rio Grande de la Magdalena. It is rich in history, having been for a long time the most important way of communication and transport in the country, the backbone of its development. The Sogamoso hydroelectric project is located in the department of Santander in the northeastern part of Colombia. The project involves the use of the Sogamoso waters, a tributary of the Rio Magdalena, for the production of electricity. The main works that make up the project are located in the stretch where the river crosses the mountainous region of the Serranía de la Paz, 62 kilometers downstream of the confluence of the rivers Anchicomocha Suarez, and 75 kilometers before emptying into the Rio Magdalena. In 2009, Isagen, the Colombian enterprise dedicated to the generation and distribution of energy, commissioned the main contractor, the Grupo ITC SRS, for the construction of the main works of the project, civilians included. The Grupo ITC SRS is a Colombian company, Salini Impregilo 100%. The diversion system is the set of structures and tasks needed to divert and channel the river so that it is possible to construct the dam. The first key step to begin the construction of the dam is the temporary waters diversion of the Rio Sogamoso, essential for preparing the riverbed where the foundations of the dam will be placed. This stage was possible through the construction of a bypass, located on the left side of the river, consisting of 2 concrete line tunnels, 11 meters in diameter and 830 and 860 meters long respectively. At the entrance of the tunnels, a concrete structure lodges 4 gates, which are kept open to allow the free flow of water during the construction of the dam, and are lowered to close the tunnels when everything is ready to start filling the reservoir. The diversion of the great rivers is undoubtedly one of the most fascinating matters that you may encounter in the construction field. In fact, in a few other cases, the engineer has the impression of not having to deal with a lifeless material, which can bend and arrange for their own ends, but with a living creature difficult to master. On the 28th of January 2011, with the diversion of the river Sogamoso, the first phase of the project was concluded to begin the second phase of construction, focused on the construction of the dam founded on the excavated riverbed. The Sogamoso River diversion begins with the opening of the intake and outlet channels, thus allowing the free flow through the diversion tunnels. When this is achieved, the natural riverbed is closed with 2 cofferdams, placed conveniently upstream and downstream of the dam foundation footprint. The upstream cofferdam has the function of blocking the river, forcing the water to flow into the diversion tunnels. The elevation of the cofferdams has to guarantee safe conditions against overtopping under the maximum flood expected during the construction period. For the upstream cofferdam, this is required reaching an elevation 50 meters above the riverbed, placing a volume of 800,000 square meters of rock and clay. With the construction of the cofferdams, the river is naturally channeled into the diversion tunnels, while in the area within the upstream and downstream cofferdams, the excavation of the dam foundation starts. Once the foundations are prepared, we proceed with the filling of the dam embankment, using selected materials coming from the excavations of other structures of the project and alluvial material from quarries, pits, located in the Rio Sogamoso Valley downstream of the dam construction area. The screening and crushing plants are located close to the borrow pits. These plants are processing the natural alluvium to produce the aggregates and sands needed in the filters and concretes. The bulk materials and those produced by the plants are transported to the dam site by special trucks along dedicated temporary roads built specifically to be safely travelled by heavy-duty vehicles. The dam embankment is filled in stages, with a total volume of 8.9 million cubic metres and reaching the required quota of 330 metres above the sea level. All these activities are carried out in compliance with the safety standards and the design requirements. The dam is a concrete-faced rockfill with the upstream slope protected with a reinforced concrete slab in order to ensure the impermeability. At the end of the construction, the dam measures 190 metres high, 345 metres wide at its highest point, and a footprint of almost 500 metres along the river alignment. The spillway is an essential element for controlling the level of the water in the reservoir, created by the damming of the river. The spillway of the Sogamoso hydroelectric project is located on the left side of the dam. The control structure consists of 4 spillway weirs, 15 meters wide, each one controlled by a radial gate 20 meters high. From the gates, the water is funneled along a chute channel, running for 350 meters into the final flip bucket, meant to dissipate into the air part of the energy. The spillway prevents the dam overtopping by releasing the excessive inflow of water into the reservoir and maintaining its level at the desired elevation. The area of influence of the Sogamoso hydroelectric project involves the department of Santander. Among the most important cities of this area, there are Bucaramanga and Barranca Bermeja. The dam and the reservoir are located within the municipalities of the city of Betulia, Zapatoca, San Vicente de Chucuri, Lebrija and Los Santos. And downstream from the site, the municipalities concerned are Barranca Bermeja, Puerto Vilches and Sabana de Torres. The water begins its run in the hydroelectric plant through the intake structure, entering a hydraulic circuit of underground tunnels and shafts down to the turbines, placed 150 meters below the average level of the lake. The circuit consists of 3 independent head race tunnels and shafts, each of which feeds a turbine. From the intake, 3 adduction tunnels, 130 meters long and 8 meters in diameter, branch out. These are followed by 3 vertical shafts, each 95 meters deep and 8 feet in diameter, and then a horizontal section, 180 meters long, down to the turbines. All the hydraulic circuit is lined with concrete, and in the last 120 meters with 30mm thick steel plates embedded into the concrete to resist the high pressures. To control the water intake, the upper sections of the 3 penstocks are equipped with gates. The gates are operated in vertical shafts, 100 meters deep, from an underground cavern. The intake structure is a concrete box-shaped building, 110 meters long, 20 meters wide and 25 meters high. The external walls of the structure are provided with metallic grids to prevent the entry of external elements such as logs or debris, which could damage the turbines. energy generation process begins when the water stored in the reservoir enters into the head race tunnels and through the hydraulic circuit reaches the generating units. The generation system is located in 3 underground caverns. Each cavern is provided with their respective access that merge into a tunnel 350 meters long. The project required the construction of other auxiliary galleries to allow access to the different internal areas, both to perform maintenance or repairs and also as potential safety escape routes. The powerhouse, which is located in the biggest cavern, is 142 meters long, 24 meters wide, and 49 meters high. Inside the cavern, there is a concrete structure composed of several levels where the electromechanical groups, the group of turbines and generators, are housed. The drainage pumping system, designed to remove the water filtering through the rock, is located in the bottom level, more than 55 meters below the floor level. The assembly of turbine and generator transforms the hydro energy into electrical energy. The 3 turbines are of the Francis type with vertical shafts. Each generator provides a rated capacity of 280 megawatts for an overall of 840 megawatts. The 3 generators together weigh 1,800 tons combined. The electricity produced by the generator is conveyed to the transformers located in an adjacent cavern. Here the electricity is raised to a higher voltage in order to connect to the external transmission lines and reduce power loss. Each generator feeds a transformer of 324 MVA, megavolt ampere, power. The transformer's cavern is 119 meters long, 14 meters wide, and 16 meters high. It was designed with the necessary measures to reduce the risk of damage to generating units and avoid potential fire or explosion. It is also provided with a smoke ventilation shaft, 120 meters deep, to be used in the event of fire, and with a service lift. Following the process of high-voltage transformation, the energy is carried to the surface via a vertical cable shaft, 120 meters high and 3.8 meters in diameter. Through the cable shaft, the energy exits to the surface to reach the Sogamoso substation, which feeds into the national grid power line. In the nearby machine room, there is the surge chamber, the third cavern 100 meters long, 20 meters wide and 43 meters high. Here the water is received after passing through the turbines and losing its energy. From the surge chamber, the water is returned to the Sogamoso River below the dam through a tail race tunnel. After the construction of the underground power station and all the intake structures, the closure of the Sogamoso River is carried on. This time, with the final closure of the diversion tunnels, the water starts to fill the reservoir, while a part is channeled into a gallery, the bottom outlet tunnel. This tunnel is 605 meters long and 7.8 meters in diameter and is located on the right bank of the Sogamoso. The tunnel is equipped with a radial gate which controls the water flow. The gate is adjustable with a maximum capacity of 486 cubic meters per second. By closing the diversion tunnel gates, the flooding of the reservoir begins. When a suitable level is reached, the test of the turbines can take place. During the process of filling the reservoir, to allow and preserve the ecological flow of the river downstream from the dam, the bottom outlet system will be in operation. The structure is designed to guarantee the proper downstream environmental flow, with a minimum stream rate of outflow of 85 cubic meters per second. The flooded area of the reservoir is approximately 7,000 hectares. Within the operational limits, the reservoir provides 4.8 billion cubic meters of stored usable water. Committed to contribute to the development of the region, and at the same time not to create any disruptions during the construction works of the project, a relocation program of existing infrastructure was started on the site that includes the construction of 51.3 kilometers of roads, 16 bridges, and 2 tunnels. In particular, in the flooded area, it was necessary to relocate the existing infrastructure below the altitude of 330 meters above sea level. Due to the interference of the project, it was necessary to build a new road of 11.5 kilometers in the Capitancitos to Puente La Paz section to restore a part of the road section that connects Bucaramanga and Barranca Bermeja. This road section includes the construction of 6 new bridges and the construction of 2 tunnels, VL1 and VL2, 1,080 meters and 248 meters long, respectively. The stretch between Lisboa, La Canana, which is part of the road connecting Bucaramanga to San Vicente de Chucurí, has been replaced by a new road, parallel to the existing one. The road section also has 5 bridges, including Puente Pujamanes, Puente El Tablazo, and Puente El Ramo. The bridges Geo von Lengerke and Guillermo Gomez Ortiz have been replaced by new bridges with respective road links. Since the power plant comes into operation with an installed capacity of 820 megawatts, it will provide an average annual production of 5,056 gigawatt hours, increasing 50% the annual electricity production of Isagen and 10% of the national production. The Sogamoso hydroelectric project is one of the 5 largest plants in the country. As a whole, it is a vision of the future and an opportunity for social development and an improvement of living conditions, which takes into account the environmental, ecological, and social area concerned.